Hey everyone, this is Rob here. Welcome back to the channel and welcome back to IP Subnetting Part 3. And in this video, we're going to be reverse engineering a subnet mask to find the network range. So say you have a computer or you're looking on an interface on a router or a layer 3 switch or what have you, and you see the IP address and the subnet mask, and you need to figure out, what range that network covers, what is the network ID, what is the broadcast, that sort of thing. So actually, if you've been following along and have watched videos 1 and 2, you should actually already know how to do this, because I kind of accidentally covered this ahead of time because it's part of the way that you do the utilize the other techniques shown in the last 2 videos. Which is finding the increment. So if you've seen those videos, this should actually be pretty easy. And then after that, we're going to find the network ID using a Bitwise AND operation. So I'm a bit limited on time today. I'm just afraid if I push this video back, to a time where I, would think that I would have more time in the future, if that makes any sense, I might not ever get to it. Or it might be a very long time. My schedule is kind of up and down and all over the place. So I figured I have a small chunk of time right now, and I'm going to utilize it to try to get this part 3 out to you guys. And with that being said, I'm just going to use one example, but it should cover the basics of it. So if you apply this to anything else, you should be able to get around pretty good. So, all right, with that being said, and without further ado, let's get into it. And if we look on the screen here, we have an IP address of, and we're still using Class C addresses. I think that's the easiest for now. I may actually release a part 4 where I go over this stuff using like a Class A or a Class B address that's been subnetted. It's pretty much the same. The only reason I'm sticking to Class C right now is because we're just working with the 3rd octet, so finding the network range is a lot easier. I don't really know exactly how to explain it without demonstrating it, but when you get into when you're working with subnetted Class A and B networks, working with the the second. Did I say the 3rd? I meant to say we're working with the 4th octet. So when you're working with subnetted Class A and B networks, you are working with the 2nd or 3rd octet, and your range is going to be it's not difficult to figure out. It's just going to throw you a little bit if you're used to, say, like a classful a Class C address. Say like this one, 192.168.1.46, this IP address, and say it was a /24 in its classful state, you would know that the network range would be 0 through 255, which would give you 256 addresses, 254 usable, because the .0 would be the network ID and the .255 would be the broadcast. But say it was a subnetted Class A address, and depending on how it was subnetted, your range might be 10.1 .0.0 through 10.3.255.255. So I know some of you that might already have a grasp on this might be like, well, what's the big deal on that? I just don't want to throw anybody with that right now, because when I first started learning about subnetting, I was watching videos, and it was, they were getting into that stuff, and I'm like, oh my god, I'm never going to get this because it's just too, So starting off with the Class C, I was able to learn the concept and then eventually be able to apply it to other ranges or other classes of IP addresses. So anyways, without further ado, I know I said I was short on time, and I'm just rambling on, so let's get into it. And if my pen would stop, I don't know what's happening. It kind of has a mind of its own right now, apparently, so let's try to... All right, stop. Whatever you're doing. The IP address we're looking at is 192.168.1.46, and it's a /27 in CIDR notation. the subnet, that would make the subnet mask 255.255.255.224. So what we need to do is we need to figure out where this network starts and where it ends. So preferably figuring out what the network ID is and what the broadcast address would be. So just like you've seen in part 1 and part 2, here we go again. I'm not exactly sure what's going on with this pen. I don't know if maybe the battery is getting low, but it seems to want to. Hopefully we can get through this video without it just being completely messed up. Okay, so we need to find the network ID and the broadcast. So just like in videos 1 and 2, you want to start with your chart. So we're going to write out 128, 64, 32, 16, 8, 4, 2, 1. So remember, binary works in powers of 2. Okay, this has got to stop, otherwise. Okay, I apologize. I may have to pause the video for 1 second while I figure this out. This is just going out of control and wanting to essentially just move everything around and resize it, and it's becoming a giant pain. So I may have to pause the video and figure this out, and then we'll get right back to it. Okay, hopefully the issue is resolved. And for those of you looking to get a Surface Go, probably don't. Because every time I actually need to use this thing for what it's actually made for, like its portability and like drawing on the screen and stuff, it hardly ever works the way it's supposed to. So I feel like when I bought this like $600 or whatever it was, including this keyboard flip cover thing and everything, I mean, that's a lot to pay for a little 10-inch computer with a Pentium Gold processor, you know, and 4 gigs of RAM, you know, that is supposed to be portable, and then when you go to draw on the screen, I mean, that's how they advertise it. That's in the commercials where you see the person with the Surface Go and they just whip it out and start, you know, they draw out their diagrams and everything on the screen. Yeah, anytime I try to draw on it, things go crazy, and it just doesn't work, and it's just a big hassle, and it's really irritating to me because, you know, when I pay money for something, I expect the product to work the way it's advertised. And the other thing, too, is, if you can see on the screen here, there's also, see that dead spot? There's also been just a complete dead spot on this the right-hand side of the screen since I first got this as well, which is like, why is it like that? And I've read, I've been on Reddit and stuff and seen that a bunch of other users are experiencing this problem as well. So, anyways, I apologize for the small little rant there. I know this isn't supposed to be a Surface Go review video, but it's like, man, you know, when I set out to do something and I have, you know, limited time to do so, and I just can't even rely on the technology I have that's specifically made to do a certain thing to do just that, it just starts to get me irritated. So, okay, anyways, back to the video. Okay, so we have our chart at the top, so 128, 64, 32, 16, 8, 4, 2, 1. And what we need to do is we need to find our increment. So if we look up here, this IP address, this it's a /27 in CIDR notation. So if you don't know what it is in CIDR notation, then you would look at the subnet mask and you see this 224 here. This is where this is the octet that we're dealing with. So the 4th octet. Look at the 224. You know that it's been subnetted based on that 224. And you essentially want to add up how many bits does it take to get to 224. So 128, 64, 32. Let's see. Yeah. So 3. So we have 8 bits right here, 8 bits right here, 8 bits right here, and then 3 bits right there. So 8, 8, 8, 3 equals 27. So that's what this CIDR notation right here is showing is that it takes 27. It's 27 bits. So just like you've seen in the last two videos, so we look where we've deviated from our classfulness. So a class C, if this was a class C address, it would be a /24 instead of a /27. And so we have borrowed bits from the host portion and added it to the network portion. So we've added those 3 network bits. So we know that we want to look at this 4th octet, and that's where we want to start looking for the increment. I mean, obviously, because if we look at a 225, I mean, that would be all of these, the increment would be in 1. So if this was classful, obviously the next network would be 192.168.2.0, 3.0, 4.0. So anyways, yes, since we've subnetted it, we need to find the new increment. So we already figured out that this /27 equals 3 bits. So 3 additional bits from the network portion are added to the network portion, borrowed from the host portion. So if we look at the chart, we see that the last one is on 32. So again, just like you've seen in the last two videos, this is how you would find the increment. Once you find the increment, you can find all of the network ranges by looking at that increment. So the way we would go about this, now that we found that the increment is 32, is look at this address one more time. Excuse me. Apologize about that. We'll look at this IP address, and so we know that it's, well, we don't know that it's in the 192.168.1.0 network. So because, again, it's subnetted, but we're going to start with the .0 and work our way up. So 192.168.1.0, 32. Oh, and here's that spot on my screen where it wants to mess up. 32, 64, 96, and I'm sure everybody watching this video has probably already spotted this, but we see, so our IP address is 192.168.1.46, so that would fall in between the 32 and the 64, this IP address. So we know that the network is going to be 192.168.1.32. That's the network. So this .32 would define the network, just like in a classful address or a classful network. The .0 would define the network. So that means that the first network here, this one, so the .0 defines the network, but since it's a /27, or assuming it's a /27, I mean, this could be broken up into smaller subnets. This could be a couple /30s or something, but I mean, it would always be better to put those at the end, because then you're going to end up with overlapping subnets otherwise. But assuming this is also a /27, that means that its range would be 0 through 31. So for this first network, the .0 would be the network ID, and the .31 would be the broadcast. So the next network, which is the network we're looking at up here, is 192.168.1.32 network /27, and then 32 through, and we see the next network starts at 64, so it would be 32 through 63. God, this is just getting out of control with this writing. I know my writing is bad as it is, but this just makes it worse. I mean, my writing is bad as it is, writing on paper. Writing on a computer screen makes it even worse, and then having a computer screen that doesn't want to cooperate makes it even worse. But that would make anybody's writing bad. So I apologize. I apologize about the bad writing, but I don't apologize about the problem with my screen, because that's not my fault. So anybody that has a problem with that, take that up with Microsoft. Okay, so 192.168.1.32 through 63. So let me rewrite this out. So our address 192.168.1.46 is on the 192.168.1.32 network. So this would actually be the network ID, and the broadcast would be .63. So 192.168.1.63 would be the broadcast, and the range would be everything in between. So the usable IPs would be 33 through 62. And if you wanted to do a quick, again, just like you saw in the last videos, if you wanted to do a quick calculation on exactly how many addresses, like hosts there would be, we look at the number of host bits. So if 3 are taken up with the network, and that leaves us with 1, 2, 3, 4, 5. So 2 to the 5th equals, wow. I should just have this off the top of my head. I don't. I do this all the time, so but I'm gonna have to bust out the calculator. I think it might be my frustration with this computer is just making me crazy right now. No, not programmer. I know everybody watching this is probably like, it's... I know some days I'm great at things, other days it's like you just have to give me a minute. So 2 to the 5th. Well, I know it's not 5, but I think I clicked the wrong button. That would be why, because I accidentally did 2. 32. So, and obviously I should have known that too, because the increment is 32. So, but anyway, so 32, 32 minus the 2 addresses for the network and the broadcast, and you're left with 30 usable hosts per /27. Okay, I really hope that makes sense. And I also wish I had more time to go over another example. But again, this being a video, you can go back and you can rewatch it. But essentially, I mean, just to recap, you're just finding your increment. So if you don't know what it is in CIDR notation, you look at your subnet mask, make your chart on a piece of paper or in Notepad on your computer or something like that, and you count up the bits to figure out what it would be to get to that, and where the deviation from your classfulness would be. So like this one being natively a class 20 or a class 24, a class C, which is the /24, 24-bit subnet mask. So you would know that there's 3 additional bits, and so you would count up all the bits and then know that it's a, in this case, a /27. But you're not really concerned about the bits before that. It's mostly those additional bits that you've taken from the host portion to subnet this, and that is how you find your increment. So what you're mostly concerned about is to make this /27, or this 255.255.224 subnet mask, 3 additional network bits are involved, which brings us to 32 being the increment, and then you can count up. So the only real pain with this method is that if you have an address that's really or say it's higher, like say it was 192.168. Actually, I'm getting ahead of myself. Let's say it was a smaller subnet. So say we had a longer prefix. Say these were like /30s, like point-to-point links. And say it was like 192.168.1.46, or I'm sorry, 192.168.1.203. So, we would know that the increment would be 4 with a /30. because we would have so the subnet mask would be 255.255.255.252, and then that would bring us all the way, I believe, here. Yeah. So the increment would be 4. So counting up, and this is why it's a pain in the butt with stuff like this, because then you're like, okay, dot 0, dot 4, dot 8, counting your way up and up and up. And so that's why what I'm going to show you right now, the bitwise and operation might be the better way to go about this. So let me go ahead and just open up a new window instead of taking the time to erase all that. And we will, let's see, write our address back up at the top of the screen. So 192. Okay. Don't move on me. I think it's because I have my hand on the screen. So 192.168.1.46/27 255 255 255 224 224. Okay. Excuse me for one moment while I take a drink here. Okay. So, a bitwise AND operation is comparing this address to the subnet mask in binary, comparing the bits, and if there is an off bit and an on bit, then it's off. If it's off and off, then it's off, but only if it's on and on. So a 1 and a 1, is it going to be on? So that might sound confusing, but I'm going to show you right now exactly what I mean. So for starters, we need to convert this whole thing down to binary. And actually, I think I'm going to convert the whole thing, but I'm pretty sure the last time I did this, I think you just have to worry about where your deviation is. So we see that this 224, and we have this 46 here. So, but I'm going to go ahead and do the whole thing. So with that being said, I'm going to make my chart. So 128, 64, 32, 16, 8, 4, 2, 1. How many of you guys are sick of me saying that by now? Okay, so let's convert this IP address down to binary. So 192. Some of this I know off the top of my head. Some of it I might have to actually use a calculator for. So we know 192 is going to be, so 128 plus 64 would equal 192. So 1, 2, 3, 4, 5, 6, 7, 8. 168 would be 1, 0, and then 3, 4, 5. I want to say 101. So 128 plus 32 would be, so take the 2, so 30. That'd be 60. And then we're looking for an 8. So 0, 0, 1. I'm getting a little bit off here. So 128, yes. 64, no. 32, yes. And then 0, 1, 0, 0, 0. 1, that's easy enough. 1, 2, 3, 4, 5, 6, 7, 8. And then the 46. Just shrink this and drag it over a little bit. So 46 would be 0, 0, 1. 0, 1. And we are hitting that spot on the screen again that wants to be annoying. Okay, so 0, 0, 1. So we have 32, not 16, and 8. So far we have 40. And then 4 and 2 equals 6, so 1, 1, 0. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I want to make sure that added up. Okay, so now we have our IP address in binary. And like I said before this, typically all you're going to have to do is worry about the last octet. But I'm just doing the whole thing because that's what you should do, especially if you're a beginner. So, okay, and then now we do the subnet mask. These first 3 octets are very easy because they're all 255s. All 255s are going to be all 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 224. And we know that from what we did before to find the increment. We know 224 is 3 additional, or 3 bits. So 128, 64, and 32. So 1, 2, 3, and then the rest are off. Come on. Okay. Now that we've done that, performing the bitwise AND operation to find the network ID, so that way you don't have to worry about those climbing those increments, is as easy as we have a 1 in a 1, so it's a 1. Same thing here. Here we have a 0 in a 1, so that would be off. So all of these are 0 and then 1, so the rest would be off. So 3, 4, 5, 6, 7, 8. Again, we have a 1 and a 1, so that would be on. 0 and 1 off, 1 and 1 on, 0, 1 off, 1 and 1 on, and then 0, 0, 0, because these are all 0 and 1. Okay, and then here we have 0 on top and 1 on the bottom for all of them except for the last, so that would be all zeros and then 1. So pretty much this is going to end up being the same thing as the beginning of the IP address, obviously, because the network ID is going to start with that. So so here we have 0, 0, 0, 0. And then here's where we're going to see some changes. So here we have 0, 1, 0, 1, so that would be 0, 0, 1, and then the rest of these would be, this would be all zeros because we don't have any match. There's no 1 and 1. It's either 0, 0 or 1, 0. So 0, 0, 1, 0, 0, 0, 0, 0. This thing on the side of the screen is slowly driving me insane. I know it's there, but then I forget every time, and then I have to redo that. Okay, so this is the network ID, but it's still in binary. So the last step, we have to convert it back to decimal, and we already know what this is going to be because we converted this part into binary, and it hasn't changed. So we know this is 192.168.1. And then here is what is going to be the network ID is in this portion. So we have 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. So 32. There you go. That is how you find the network ID using a bitwise AND operation. This looks horrible. So 192.168.1.32 is the network ID. And then, of course, if you want to find the broadcast, whatever the increment is, it's 32. So 64 would be the next. So 32 through 63. And that is it. I really hope this was easy enough to understand. Just to recap this section really quick. Performing the bitwise AND operation. You just convert the IP address and the subnet mask into binary, and then you line them up one on top of the other. So IP mask lined up, and then match up the bits. So, you know, if we had 1 1 0 0 and then 0 1 1 1, that would be 1. I'm sorry. That would be 0. So we would have 0 1 0 0. And that's basically all you're doing. Take that when you're done, convert it back to decimal, and that's how you find the network ID using a bitwise AND operation. All right, so that pretty much sums it up. Again, I wish I would have been able to do a more in-depth video, give some more examples. So with that being said, there may be a part 4, and I may take that part 4 and take material from parts 1, 2, and 3, which is this video, and essentially make part 4 a video where I just go over a bunch of different examples. So I'll have a list of some subnetting problems that we'll go over. So, you know, how to, you know, we need this many hosts, or we need this many networks, or we need to find the network ID of this, you know, that sort of thing. And I'll go over a bunch of different examples, and we'll go through it like that. So that'll be part 4 if I have the time. I mean, I'm sure I'm going to have the time. It's just a matter of when. And when that time comes around, I'll probably end up putting that out. And for anybody that's still, you know, failing to grasp the issue fully, hopefully that will clear it up a little bit more. So, but if you're still kind of, you know, like it kind of makes sense, it kind of doesn't, I urge you to rewatch the video, or go on YouTube and search for subnetting videos. I don't know if it's on YouTube or not, but one of the best subnetting videos I've ever seen, the one that actually pounded it in my head, and I got it instantly after watching subnetting video after subnetting video after subnetting video, and just not getting it, reading material on subnetting. I mean, it was like I got it, but I didn't, and then I thought I got it, and then I'm like, no, I don't have it, and then I would forget. And then I watched a video by Jeremy Chara, and for anybody that's not familiar with Jeremy is one of the absolute best Cisco trainers out there. I achieved my CCNA thanks to Jeremy Chara. I've learned so many things thanks to him. His method, his way of explaining things he's such a talented person. And even if it's not just getting the subnetting concept down, anything network or Cisco related, Jeremy Chara is going to be your guy. So him, and I'd probably also recommend Kevin Wallace, Keith Barker for sure. But man, Jeremy Chara is one of my all-time favorite network guys out there. And if you're looking for that video and you can't find it, send me an email or something, or leave a comment in the comment section below, and I should be able to find it and get it to you. But he has a way of explaining this that is just, it just hits it on the head so hard, and it's almost impossible not to understand once you get done watching his videos. So, but anyways, all right, yeah, I've got to get out of here, so I guess that's it. So thanks for watching this video. I really appreciate it. I really hope you learned something. If you're not subscribed to the channel, please, I urge you, especially if this video helped, you can show your appreciation by subscribing, giving the video a like. I don't really care so much about likes in the typical fashion, other than it just helps the ratings on the videos and, you know, stuff like that. And then, of course, if you want to express your opinion, leave a comment in the comment section below. Thanks for watching, and I'll see you in the next video.